the fabric of reality more than meets the eye. We often take space and time for granted. In our daily lives, we move through space without a second thought, and we watch the clock as time ticks away, marking the moments of our existence. Space is the vast emptiness around us, stretching out in all directions, filled with stars, planets, and galaxies. It seems infinite, a boundless expanse that we can barely begin to comprehend. Time is the steady march of moments, always moving forward, never stopping. It governs our lives from the rising and setting of the sun to the ticking of a clock, marking the passage of our days. But what if I told you that space and time are not what they seem? What if these fundamental aspects of our reality are merely illusions? Constructs that emerge from something far more profound and mysterious? What if they are not fundamental but rather emerge from something deeper? Some scientists and physicists believe that space and time might be woven from a more fundamental reality, a deeper layer of existence that we are only beginning to uncover. Imagine a shimmering, intricate tapestry. From a distance, it appears as a seamless whole, a beautiful and complex design that captivates the eye. From afar, it appears as a seamless whole, a stunning work of art that seems perfect and complete. Up close, however, we see that it's made of countless individual threads woven together. Each thread is essential, contributing to the overall pattern and structure of the tapestry. Space and time, some physicists believe, might be like this tapestry. They might be composed of countless tiny, fundamental elements woven together to create the fabric of our reality. They might be woven from a more fundamental reality that we are yet to fully grasp. This deeper layer of existence could hold the key to understanding the true nature of the universe, revealing secrets that have eluded us for centuries. As we continue to explore and study the cosmos, we may one day uncover the hidden threads that weave together the fabric of space and time, unlocking the mysteries of the universe and transforming our understanding of reality itself. Emergent spacetime, like a dance floor made of dancers. Think of a crowded dance floor. Each dancer moves individually, yet their collective motion creates a swirling, dynamic pattern. Similarly, imagine tiny building blocks of the universe, far smaller than atoms. These building blocks interact with each other, and from their interactions, space and time emerge. This is the mind-blowing idea of emergent spacetime. Space and time are not independent entities. Instead, they arise from the relationships and interactions of these fundamental building blocks. Just like the dance floor wouldn't exist without the dancers, space and time might not exist without these underlying interactions. Gravity's grand illusion, warping the stage of space and time. Einstein revolutionized our understanding of gravity. He showed that gravity is not a force acting across space, but the curvature of space-time itself. Imagine a bowling ball placed on a trampoline. The ball distorts the fabric of the trampoline, creating a dip. Similarly, massive objects like stars and planets warp the fabric of space-time. This warping is what we experience as gravity. Objects are not pulled by a force, but rather follow the curves in this warped space-time. Black holes, where gravity takes center stage. Nowhere is the warping of space-time more extreme than around black holes. These cosmic behemoths are regions of space-time where gravity is so strong that nothing, not even light, can escape. Imagine the bowling ball on the trampoline again, but this time the ball is so heavy that it creates a bottomless pit. That's a black hole. Once something crosses the black hole's event horizon, the point of no return, it's trapped forever. Black holes remain one of the most fascinating and mysterious objects in the universe. Fuzzballs. Untangling the mysteries of black holes. Black holes have long fascinated scientists and the general public alike. These enigmatic cosmic entities are known for their immense gravitational pull, which is so strong that not even light can escape from them. But what exactly are black holes, and what mysteries do they hold? Black holes present a significant challenge to our understanding of physics. They are regions in space where the gravitational pull is so intense that it warps space and time itself. This warping effect is predicted by Einstein's theory of general relativity, which describes how massive objects influence the fabric of space-time. They push the boundaries of both general relativity and quantum mechanics. While general relativity explains the macroscopic properties of black holes, quantum mechanics governs the microscopic world of particles and forces. The intersection of these two theories is where the true mystery lies. One particularly puzzling aspect is the fate of information that falls into a black hole. According to general relativity, anything that crosses the event horizon of a black hole is lost forever. However, quantum mechanics suggests that information cannot be destroyed, leading to a paradox that has puzzled scientists for decades. Quantum mechanics suggests that information cannot be destroyed, yet general relativity seems to imply otherwise. This contradiction is known as the information paradox, and it has led to numerous theories and debates within the scientific community. This is where the fascinating concept of fuzzballs comes in. Fuzzballs are a theoretical solution to the information paradox proposed by string theory, a framework that attempts to reconcile general relativity and quantum mechanics by describing particles as tiny, vibrating strings. Some physicists propose that black holes are not empty pits, but rather incredibly dense, fuzzy balls of quantum strings. These strings are the fundamental building blocks of the universe, and they could provide a way to store information in a black hole without violating the principles of quantum mechanics. These strings, the fundamental building blocks of the universe in string theory, would store information in a way that prevents its complete destruction, potentially resolving the information paradox. By reimagining black holes as fuzzballs, scientists hope to bridge the gap between general relativity and quantum mechanics, offering new insights into the nature of the universe and the fundamental laws that govern it. Quantum gravity, the quest to unify the laws of the universe. The quest to understand space and time ultimately leads us to the biggest challenge in modern physics: unifying general relativity, which governs the large-scale structure of the universe, with quantum mechanics, which describes the world of atoms and subatomic particles. These two pillars of modern physics seem incompatible at their core. General relativity describes a smooth, continuous space-time, while quantum mechanics introduces a world of discrete energy levels and probabilistic events. This incompatibility suggests that our current understanding of space and time is incomplete. The future of physics, unlocking the secrets of space and time. Unifying general relativity and quantum mechanics would be a monumental achievement. It would revolutionize our understanding of the universe and its fundamental laws. Imagine a single, elegant theory that explains everything from the smallest subatomic particles to the largest structures in the cosmos. This unified theory, often called quantum gravity, could hold the key to unlocking the deepest secrets of space and time. It could reveal the true nature of black holes, the origin of the universe, and perhaps even the possibility of other dimensions. The power of understanding, from technology to philosophy. The quest to understand space and time is not merely an academic pursuit. It has the potential to drive technological advancements and reshape our philosophical outlook. By unraveling the mysteries of the universe, we open doors to new possibilities. Imagine harnessing the power of black holes for energy, manipulating space-time for interstellar travel, or even understanding the very nature of consciousness through the lens of quantum gravity. The potential benefits of this knowledge are vast and awe-inspiring. The universe, a tapestry of wonder and exploration. It is a vast expanse that stretches beyond our wildest imaginations, a realm where the boundaries of reality blur and the possibilities are endless. The universe is a tapestry woven from the threads of space and time. Each star, each galaxy, each particle is a part of this grand design, contributing to the intricate and beautiful pattern that we are only beginning to understand. As we delve deeper into its mysteries, we discover a reality far stranger and more wondrous than we could have imagined. From the smallest subatomic particles to the largest galactic structures, the universe is filled with phenomena that challenge our understanding and inspire our curiosity. The quest to understand space and time is a journey of exploration, a testament to the power of human curiosity and our relentless pursuit of knowledge. It is a journey that has taken us from the surface of our planet to the farthest reaches of the cosmos, and it is a journey that continues to this day. So the next time you gaze upon a starry night sky, remember that you are looking at more than just empty space. You are looking at a universe filled with wonders, a universe that is constantly evolving and changing, a universe that holds the answers to some of the most profound questions we can ask. You're looking at the fabric of reality itself, a fabric woven from mystery, wonder, and the endless pursuit of understanding. It is a fabric that we are only beginning to unravel. And as we continue to explore and discover, we will undoubtedly uncover even more wonders and mysteries that will inspire and amaze us.